Good morning, students. I myself, architect Amir Inam, assistant professor at School of Architecture, Golgotha University. Today we will be studying about subject building construction, under which we will be talking about prefabrication systems. So before starting, it is very important for a student to be aware of the different prerequisites of this lecture. A student should be aware of that a construction method of precasting is very much available in India. And secondly, the definition of precast construction methods. So the objective of this lecture are pretty much clear. A student will be understanding the different prefabricated systems and their components. And secondly, there are various types of prefabricated systems available in India as well. So the student will be aware of these two types of objectives at the end of this lecture. Let us first start with the introduction part of the prefabrication system. Or a precast construction system and a prefabrication system are both the same things. So the precast construction system is generally a large panel system or a modular system or a combination of both. A precast large construction panel, which is also called as PLCP system, which consists of various precast elements such as walls, beams, slabs, columns, staircases, landings, and some customized elements that we standardize and design for stability, durability, structural integrity of the building. Precast residential building construction involves design, strategic yard planning, lifting, handling, and transportation of precast elements. This technology is suitable for construction of high-rise buildings, resisting seismic and wind-induced lateral loads along with gravitational loads as well. So, a precast construction system that involves a precast panel system or the modular system or the combination of both. So when we talk about the precast system, it is a precasted system that is precasted on not on the site but then transported to on the site and then fabricated with the help of different methods. Moving forward to the introduction part, the prefabricated system, the building which is designed in a prefabricated system is also called as the hybrid construction. A building framing is planned in such a way that the maximum number of repetition of molds is obtained. These elements are casted in a controlled factory condition. The factory is developed at or near the site, which provides an economical solution in terms of storage and transportation. So when we talk about the transportation cost and the storage cost, it is a very much necessity to clear that the site which is used for the construction of the factory has to be done very much near the site where the construction is being done. There are different types of precast concrete buildings which can be grouped as total precast, partial precast, or mixed construction structures. It is necessary to study each system for a better understanding and to arrive at an appropriate application. Total precast building comprises various precast components such as footings, beams, slabs, columns, walls, facades, etc. A partial precast can be made up of precast component and casted in place concrete members. This type of building is also known as hybrid construction. We will discuss all these components one by one in the coming up lecture. A large panel structure are one of the most progressive industrial type of structural elements. So a large panel system, structural system, is the most progressive industrial type of construction nowadays. In modern construction, they are used in building, apartment, houses, even public and industrial buildings, roads, airfields, dams, and canals. There are various fields where this type of technology has been introduced. They have been become very widespread in large-scale housing and civil construction, where the erection of buildings from large panel manufactured at housing construction combines and plants make possible a reduction of construction time by a factor of 1.5 to 2 in comparison with the erection of the building from bricks and other traditional materials or methods. So when we compare about the time taken by the traditional method construction and the prefabrication system, it is find out to be that the time involved in the precast system is 1.5 to 2 times less than the traditional method. So, as well as the decrease in the 30 to 40% of the labor expenditure. Obviously, when the time is reduced, there is also the reduction in the labor expenditure of the construction. So, the reduction of 30 to 40% in the labor expenditure also reduce the cost of the building construction. So, when we talk about the different types of precast fabricated systems, that are used during the construction in the prefabricated construction methods. We have wall panels, we have parapet beams, we have even spandrels, we have solid slab, we have pods, and we have staircases. So these all are the basic systems that involves in the precast fabricated construction methods. So a building system constitutes the basic of a building. It constitutes the individual elements like walls, floors, and roofs, as well as columns, beams, and stairs. Precast concrete elements for walls, floors, and roofs are flat construction elements with integrated building services. Walls are produced normally that are produced mostly to the floor to ceiling height. Floor and roofs are produced in a specific width and in specific sizes that depends upon the maximum size permitted to transport at a particular state to state, and also on the aesthetical requirement as well. So when there is a requirement for a reinforced precast members and a pre-stressed precast members, we have two types of precast concrete elements such as precast reinforced concrete elements and precast pre-stressed concrete elements. So this video will show you a time lapse in a construction of a prefabricated system construction, how the whole construction is being done throughout the time. So there is a transportation of prefabricated material on the site from a different factory point, which is then transported and stored in a different location. The boundary of a prefabricated system is being done and then casted in a slab. Finally, the precasted beams are used for the roof that are fabricated with different methods. So these all are well designed in a factory that involves a different level of technology to transport it to different locations. The roof has been settled down and then the panels are well settled on the walls. Even the wall panels are then fitted to complete the wall construction. The doors and the windows panels are then fixed together, and then finally they are covered with the finishing cover. So this whole construction is being done with a very much less time than the traditional construction method. The rooftop is then installed with the solar panels. So these type of design are earlier discussed in while designing the plan of this structure. The dimension of the required panels are then sent to the factory for the construction and then transported to the site. So this is the final view of the house that has been done in the prefabrication system. So we have precast fabricated system, we have some standards of dimensions and typical sizes that are used in the precast concrete elements. So these shall consist of a pre-stressing tendons when the elements to provide the required force needed to resist the external loadings, and as well as the cracks such as the hollow core, slabs, beams and planks. So we have the different precast components and their typical sizes. We have wall panels that are of a typical size of 5 meter by 2.85 meters. So we have to join all these components together to have a clear width of the room. We have a slab that is a dimension of a 3 meter to 5 meter. We have pods which has a dimensions of a 1.52 meter into 1.36 meter into 2.83 meter. We have beams of typical dimension of zero point 0.2 to into zero point 0.4 into a required length, and we have a staircase that have no typical size. We can design it as per the customized design, and we have a typical column size of zero point 0.9 by 0.35 by 2.85 meters. So we have to join different columns together to finally get a desired length of the column. So in general, precast building system are more economical when compared to the conventional construction technology, even in the residential or any different types of buildings. And this method is being used in various countries as well as in India as well. So moving forward to the precast system component, we have a mold system. A mold for precast element shall be of a steel and concrete. For design of a mold for various elements, special importance should be given to easy demolding and assembly of the various parts. So we have three types of mold system. We have the battery mold, we have the tilting mold, and we have the pod mold. At the same time, rigidity and strength and water tightness of the mold are also important, taking into consideration forces due to pouring of green concrete and vibration. So we have a mold type and their typical uses. We have a conventional mold that are used in a ribbed slab, construction of a ribbed slab, beams, window panels, box type units and special elements. We have a battery modes that is used for the interior wall panels, shell elements, roof and floor slabs. We have a tilting molds that is used for the construction of exterior wall panels where special finishes are required on face for the sandwich panel. We have a long line pressuring beds for the construction of double T's, ribbed slabs, piles and beams. And finally, we have a mold type of extension machine that is used for the construction of a roof slabs and hollow core slabs. So a typical a kind of use that has been to be done on the site for the construction of a precast system. There is a typical mold type that is being used for the construction of that component. So moving forward to the precast fabricated components, we have beams. We have a precast beam system and we have two types of precast fabricated beams. We have the internal beams and we have the external beams. So internal beams are used where floor loading is approximately symmetrical, and external beams are used where the floor loading is predominantly not symmetrical. So what is a symmetrical loading is when we have a floor, we have a floor span and there is a symmetrical load on each and every part of that particular slab, and we have an external beam where the floor slab has a non-symmetrical loading. So we can have a points where the load is more and we can have a points where the load is very much less. So these two types of beams are used for the precast fabricated components. So another typology of precast fabricated component are the columns or the precast columns. So for structure of 5-story or less, each column will normally be continuous to the full height of the building. But when we have the building height which is more than 5-story, so the number of columns that are spliced together have to be in a typical manner pointed towards each and every face. So when we have the story, when we have the building which is more than the 5 story, a certain height, the number of columns that are used can be more than one. And when we have the building height which has the number of story less than 5, a continuous column can be used that can be fabricated or customized accordingly to the design. So when we talk about the precast columns, we have three types of precast, mainly three types of precast columns, that are edge columns, which are symmetrical in one direction. We have internal columns, which are symmetrical in all direction, and we have corner columns, which are not symmetrical at all. So each and every typology of corner that has to be used in a design has a separate name and has a separate design technique. Another component in a precast fabricated system are the floor slabs or the precast floor slabs. We have many types of precast floor slabs. Here I am explaining you the two basic types of precast fabricated floor slabs, the hollow core slab and the double T slab. So there are main types of slab that are used in the precast frames are the hollow core and the double T. So in a hollow core, which has a width of around 1200 mm and a depth of around 100 to 400 mm, and a T slab which has a width of around 2400 mm and a depth of around 300 to 800 mm, with a span of around 24 meters. So when we have a large span, when there is a requirement of a large span, we use the double T slab, and when there is a requirement of a smaller span around 15 to 20 meters, we use the hollow core slab. So these hollow core slab, as you can see in the picture, have the core that can be used for the services as a services ducts, and the double T slab has to be then fabricated by the false ceiling as well. So in a precast fabricated walls or the precast walls, it serves two functions. The stability, because the walls or the wall box surrounds the staircase as well as the lift shafts as well. It has to be stable because the wall also supports the different components, and walls can be classified into as infill and cantilevered. The infill walls rely on the continuous composite action with the beam and column frame, while the cantilever walls or box act as a deep beam to which the frame is attached. Moving forward to the precast fabricated components, we have precast staircases. A precast staircase is a well-designed staircase that is used to connect two different floor levels and to connect at a different height, or to connect two floors with the precast staircase. It is similar to the normal traditional staircase system, which is designed not on the site and then transported and then connected with different methods of connections. So precast staircase, three options are available for precast staircase. A single precast unit containing all the flights and landings, separate precast flights and landings, parts of flights and landing are made in one piece. So we have three different types of precast staircases. We have a single module, a single block of staircase that is being transported on the site and then fabricated with different components. And then we have different subcomponents of the staircases, for example the flight and the landings, and then they are connected on the site and then finally connected as a group and then molded in the form of a staircase and finally done with the different components of the building. And another the last part of the method is the part of the flights and the landings are made in one piece. So when we talk about the precast technology or the precast fabrication method, we have two different widely accepted systems suitable for the building construction. We have the large panel system, which are used for the construction of a different typology of buildings. We have different panels that are connected, and then we have a frame system in which the frame first is constructed and then the panels are attached to it. So when we talk about the precast technology, we have a standard three-step technology. First, those members or the components that are being designed in a factory are have to be well designed and well labeled. They have a certain number of coding on them so that they can be connected with ease on the site. So the structural element are first standardized and then casted in a factory. Secondly, those elements are well equipped with in a particular coding boxes, and then they are transported on the site. And then finally, they have erected on the site by the help of the cranes and the levers. So these three-step technology is being used throughout the prefabrication system method. So the standardization of elements and the erection of those components on the site are those two important steps in a prefabrication technology. The coding that has to be done have to be a very in a very proper manner so that no component can be used or misplaced at the time of the erection of the component on the site. Finally, if we talk about the structural panels, and we have a different type of structural panels in a prefabrication system. We have open and closed systems. In an open structural panel system, a pre-assembled wall framework which has been later fitted with other elements such as insulations, ducting systems, vapor control system, external claddings and all on the site. So the whole component is being used and then other components are then added on that. While this is quick and flexible compared with the traditional construction method, it is still a lot of site work has been involved in this type of open structure system. But in contrast to a closed structure system, a closed structure system is a pre-assembled wall panels with the other element including such as the pre-fitted windows, even doors, ducting and internal services, even the finishes, tiles, claddings and all have been already fitted with the component and then transported on the site. So if we compare the open and the closed system, a closed panel tends to be a larger and heavier if we compare it with the open system, but it is very much easier to install a closed structure system than the open structure system. So when we talk about the prefabrication system in our structural panels, uh, usually in India we are much more towards the open system rather than the closed structure system. So concluding the lecture, these are some points concluding the lecture that precast concrete is a construction product produced by casting concrete in a reusable mold or form, which is then cured in a controlled environment, transported to the construction site, and lifted into place, all tilted up. In contrast to standard concrete, which is poured on site, specific forms, and cured on site, which takes a lot of time and labor. There are many different types of precast concrete forming system for architectural application, different in size, function, and even cost. Precast architectural panels are also used to clad all over the part of the building facade or free-standing walls used for landscaping, soundproofing, security walls, and some can be pre-stressed concrete structural systems as well. A concept of precast construction includes those buildings which are majority of the structural components are standardized and produced in plants in a location away from the building and then transported on site for assembly. These components are manufactured by industrial method based on mass production in order to build large number of buildings in a very short and low cost. So if we move forward to the reference part of this lecture, you can go through these references for your further enhancement of knowledge on the precast fabrication system or the more information about the different methods of precasting systems. Moving forward to this lecture, I have three questions for you in a form of your assignments. Why prefabricated systems are more economical than the traditional method of construction? What are the different components in a precast fabricated system? Explain them with proper examples. Explain the process of precast technology in context of precast panels. So these three questions are your assignments and you have to submit it. In the next lecture, we will move forward and give a detailed analysis of the different components of the precast fabrication system. Thank you.